Hello everyone, welcome to CSCI453 Digital Image Processing. In this video, we will talk about how to crop an image. A digital image is an array of pixels, each of which is indexed by row and column. Cropping an image is extracting part of the pixel array as a new image matrix. For example, the image on the left is a full image, and the image on the right is a cropped image. The red rectangle indicates a preserved area after cropping. To obtain the cropped image on the right, we need to obtain coordinates of the upper left and bottom right corners of the red rectangle. The cropped image consists all rows between the rows index of the upper left corner and the row index of the bottom right corner, and all columns between the column index of the upper left corner and the column index of the bottom right corner. The cropping process can be considered as extracting a subimage from the original image matrix, which can be easily achieved using MATLAB matrix indexing. In MATLAB, each matrix element can be located using subscripts or linear indexing. For example, assume we have a matrix M of size 3 rows by 4 columns, as shown on the left. We can locate any elements in M as shown on the right. The subscripts use row index, the red number, and the column index, the green number, to locate a unique element, while the linear indexing number each element in the matrix from top to bottom and from left to right. You can see the blue numbers. For instance, M with the parenthesis 2, 3 indicates the intersection of the second row and the third column, which is 7 in M. If linear indexing is used, the same element can be located as M with the parenthesis 8. In addition to subscripts and linear indexing, the colon operator can be used in the matrix indexing to offer a convenient way to specify a set of elements in the matrix. There are two ways to use column operator in matrix indexing, including all and to. When column operator is used alone in matrix indexing, the operator means all. For examples, M parenthesis column, comma, 4 means all rows in column 4. Another example, M parenthesis 3, comma, column means all column in row 3. The second usage is that when column operator is used together with numbers in matrix indexing, the operator means to. For example, M 2 column 4, comma 3 means in column 3 from row 2 to row 4. So the blue rectangle indicates the row 2 to row 4, and the comma 3 is indicate a column 3, which is shown in the green rectangle. The intersection of them is shown in red, so the M 2 column 4, comma 3 indicate the red rectangle elements. Another example, M parenthesis 1 to 3 comma 224 indicates the first row to third row and the column 2 to column 4. So the intersection of the index is the red rectangle. With either subscript or linear indexing, you can select a subset of elements from matrix. For example, assume we have a matrix V, where the index of the matrix is shown in the first row and the content of the elements is shown in the second row. So V3 retrieves the content stored at index 3 in V, which will give you 9. V with a parenthesis and the square bracket 156 will retrieve the content stored at index 1, 5, and 6 in V, which give you 16, 2, and 11. If you enter V parenthesis square bracket 3 to 7, this will retrieve the content stored from index 3 to index 7, which will give you 9, 4, 2, 11, and 7. We can also assign the retrieved content to a new matrix. For example, V parenthesis square bracket 5 column 8 1 column 4 will retrieve the content stored from index 5 to index 8 and then from index 1 to index 4, which will give you the new vector v2 as shown on the screen. Also, you can use AND in the matrix indexing. The AND indicates the index of the last element. For example, V parenthesis 5 to AND retrieves the content stored in the index 5 to index 8 because the index of the last element in V is 8. Similarly, you can use AND in the following ways to select a subset of elements. In addition to subscripts and linear indexing, MATLAB also provides logical indexing, which allow user to select a subset of elements from a matrix by comparison. For example, assume our goal is to select all elements that is greater than or equal to 7 in the matrix M, as shown on the left. We can evaluate which elements in matrix M are greater than or equal to 7. The comparison will result in a logical matrix as shown on the right, where 1s indicates true and 0s indicates false. If we store the produced logical matrix in a variable IDX index, we can use IDX as an array index to retrieve all elements that is greater than or equal to 7 in the matrix M. Please continue to watch Week 3, Unit 4, Hands-on Practice HP04 video for detailed step-by-step instruction to practice what you have learned from this unit.